All right, so we're gonna hit the eye in this one. If you'll notice, I'll give you a second, what eye do you think that this is? It's your right eye. So if we use our spatial reasoning, we can see that this is the nose. This is the medial portion of the skull. We've got our lacrimal duct here. Also, we've got this structure back here. What do we think this would be? It's actually your internal carotid artery running up through the medial portion of that skull, going to supply the brain with blood. So looking at this eye, we've got our lacrimal gland over here. This is going to be responsible for supplying fluid into the eye, keeping it moist, and then whenever that fluid has done its purpose, it will be drained into that lacrimal duct and then dropped into the venous supply to be recycled. So the structures that we will look at first, this most outer portion here is going to be our cornea. This actually lacks blood supply. So that's why if you ever scratch your cornea, it takes an extremely long amount of time to heal. However, it does have a large capacity of nervous supply, so that's why it also hurts, I can't say that anymore, really bad when you do scratch it. Okay? So yeah, behind that, we're gonna see the colored portion. That is our iris, all right? So everyone's iris is gonna be a little bit of a different color. We will see on this back side, they're called ciliary bodies, but they're little muscles that are attached to little ligaments that will then pull on the lens, which sits behind here. And that will be adjusted depending upon, are we looking at something close or am I looking at something far away? And the lens is actually a malleable, like bouncy ball that over time becomes stiffer and harder to move. That's why when we're younger, we can see things better, and then as we get older, it becomes harder to read things or see things further away. We are not going to get into the nitty-gritty of accommodation, that's what that's called, as well as the specifics of the eye. That's another topic that you're going to cover with Dr. Rhodes in Human Body 2. But what we can also see is, this model doesn't do a very good job of it, but lining the inside of the eyeball on that posterior portion, the retina would sit kind of back here. That's what's responsible for interpreting the pictures that we see. Like I can see that Maggie is wearing a gray shirt that says reading is fundamental in blue lettering, okay? Yes. So looking at the structures that are responsible for moving the eye, and we'll put up some supplementary info to help you with this if it's not already up. We're gonna have 6 muscles that we're gonna talk about. We're gonna have some rectus muscles, which rectus means straight, and then we're gonna have some oblique muscles, that means, like it sounds, oblique comes at an angle or diagonal. So this top muscle right here is gonna be my superior rectus. This is gonna be innervated by cranial nerve 3, oculomotor. So a muscle, and we'll get into it more when we talk about muscle physiology and mechanics and things like that, a muscle will attach to 2 places. It's going to shorten and it's going to pull on whatever it's attached to. All right, so it's going to get shorter. So if I'm attached back here at the posterior portion of my orbit and then attached onto my eyeball here, if I follow those fibers, all right, superior rectus is going to be responsible for me being able to look up. Okay? This outer one here, this is going to be my lateral rectus. Okay, one thing here that's key is that you understand your directional terminology. So lateral rectus is responsible for giving someone the side eye. Okay, so when we were in middle school and we were really mad. Okay. Our medial rectus inside here is going to pull our eye inward. Okay, I've noticed I also cannot cross my eyes very well, so I tried really hard on that one. But if you can't see it, just know that's what it does. And then below, on the bottom, it's kind of hard to see on this model, but if we look at the back side, this is going to be my inferior rectus, responsible for pulling my eye down. So now these muscles can work in combination with each other and do more than just one action, but for this class, just know the one action that I'm giving you. We're also going to have the oblique muscles. This is where they become a little tricky. We're going to have superior oblique that's on the side here, the medial side. Now, the reason why it becomes a little tricky is it runs around and it loops through this hammock thing. This is called a trochlea, all right? And it's innervated by the trochlear nerve, cranial nerve 4. And the tendon is going to go and it's going to attach kind of on the back side of the eye. And when it does, as it shortens and pulls, so if this are my muscle, this are my tendon, my head is the eyeball, as it shortens and pulls, it's going to pull my eye down and out. That seems a little counterintuitive. So superior oblique pulls the eye down and out, right? So then inferior oblique, which you can see right here, same thing. Muscle attachment will come around, attaching onto the inside or more medial posterior portion. As it contracts, it'll pull the eye up and out, all right? Again, a little counterintuitive to what we would normally think. So spend time with that. Also, we can see cranial nerve 2 here. That's going to provide sensory information to the eye. So us being able to feel pain, burning, things like that. So some of the weird innervations here. Lateral rectus is innervated by cranial nerve 6, abducens. Superior oblique is innervated by cranial nerve 4, trochlear nerve, and then the rest of the muscles are innervated by cranial nerve 3, oculomotor. That's all I've got for you.